Hello, scholars. Welcome. This is Ms. Kraft. Today we're going to go over ionic bonding. We're going to start with, of course, as I love to start every course with, let's start with a chemistry joke. So the name's bond, ionic bond, taken, not shared. Okay, if you have to explain the joke, then it's not funny, but sometimes it's good to explain the joke. So, in an ionic bond, the electrons are taken from the metal and they are given or donated to the non-metal. So that's why this joke is funny. Where covalent bonds, which we're going to talk about later, that's when the electrons are shared. Okay, so that's our joke for the day. All right, so the first thing is we're going to start off with a little bit of a review. With valence electrons, and make sure that right now I want you guys to pause the video and I want to make sure that you have out your periodic table and make sure you also have out a notebook so that you can keep some notes as we go. Okay, so the first thing we're going to do is we're going to make sure we know how we can get our valence electrons. Okay, so we're going to label this periodic table with our group numbers. Okay, so this first group right here, this is going to be group 1. Okay, so that means all of these all the way down, hydrogen, lithium, sodium, all the way down. That means they have one valence electron. Okay, now we have our second group. Okay, so that means all of these all the way down, they have 2 valence electrons. Remember the valence electrons, these are the ones that are most active in the element. These are the ones that are going to be doing the chemical bonding. That's why they're so important, and that's why I want to talk about them. All right, so group 13, some of you guys were putting that they had 13 valence electrons, but remember, even though it's group 13, they only have 3 valence electrons. Okay, so this group all the way down all have 3 valence electrons, and now we have carbon. Carbon group, they all have 4 valence electrons all the way down. Okay, and then it goes to 5 valence electrons, and then we have 6 valence electrons all the way down, and then we have 7 valence electrons, and then we have 8 valence electrons all the way down. And remember about the octet rule, and these noble gases, they're very stable and happy. Okay, so they don't bond with other elements. Okay, because they already have already reached the octet rule. All right, so that's just a little review on valence electrons because they're the most important for us to know about when we're getting into bonding. All right. Another review on Lewis dot structures. Okay, we're gonna bounce a little bit back and forth between the periodic table, so make sure you have yours out. I'm gonna do a couple of examples, and then I'm gonna have you do the rest of them on your own. Okay, we're gonna start with sodium. So to be able to figure out how many valence electrons I have for my Lewis dot structure, okay, I'm going to go and I'm going to find sodium. Sodium's right here. It's in group 1. So I know that it has 1 valence electron. Okay, so if it has 1 valence electron, that means I'm going to start at the very top here. And I'm going to put 1 valence electron. Okay, so sodium has 1 valence electron. All right, so that's what I would write for the Lewis dot structure. A little review on the Lewis dot structure. Remember, you have to put 1 electron on each side, okay, of the element symbol before you can start pairing up. All right, so we're going to get a little practice in that in the next one. So let's find oxygen on the periodic table. So let's go back to the periodic table. We find oxygen. Oxygen's right here. And if I go to the top of that group, it has 6 valence electrons. Okay, so this one, I have to put 1 electron on each side before I can pair them up. All right, start at the top. So I have 1, okay, 2, 3, 4. Okay, so I have 1 on each side. Now I can start pairing up. Okay, you have to make sure you have one on each side before you start pairing. So now I have 5, and then I have 6. Okay, so later on, this is going to be important because this means oxygen is missing 2 electrons it wants to complete the octet rule. What I want you guys to do right now is I want you to pause the video and I want you guys to finish, and I want you to do magnesium, aluminum, fluorine, and xenon on your own. Okay. All right, welcome back. So now we're gonna check to see how you did on your answers. So magnesium, you should have saw on your periodic table that it's in group 2. So magnesium gets 1 and 2 electrons, okay? Notice I'm going in this clockwise fashion. So aluminum is in group 13, so it gets 3 valence electrons. So 1, okay, 2, and 3. Okay, fluorine is in the halogens group, and halogens have 7 valence electrons. So this one, I know I'm going to do 7, so I got to start at the top. So 1, 2, 3, 4, oops, 5. Guys, I'm a little bit new with this pen thing. It's pretty fun, but yeah, as you can see, I'm struggling a little bit. Okay, 6 and 7. Okay, so that leaves 1 spot open right here because fluorine needs 1 more electron to complete the octet rule. So hopefully these look exactly like yours do. Now we have xenon. Xenon is a noble gas, so xenon has 8 valence electrons. Okay, see if I can make this one a little bit look a little nicer. Okay, so we have 1, 2, 3, 4, and now 5, 6, 7, and 8. Okay, that one was a little nicer than fluorine, so getting better. All right, so here we have, so that's a quick review for Lewis dot structures. If you're still struggling with that, please practice with some more of them. All right, so let's go ahead and move on. All right, now I want to talk about ion formation. This is also another review. Okay, if you have less than 4 valence electrons, then that element is going to donate or lose all of its electrons. Okay, if you have 4 or more valence electrons, that element is going to gain electrons to get to 8 electrons to complete the octet rule. Okay, so another way you can remember it is that metals are losers. I should do this way. Metals are losers, okay? So they're going to lose electrons. So if it's a metal, just know that it's a loser and it's going to lose the electrons. And that means they'll lose the electrons to the non-metal, okay? So if it has 4 or more valence electrons, that is because it's non-metal. And non-metals are always going to gain electrons. All right, so when an atom or an element loses electrons, they become more positive, okay? Because it has more protons than electrons. This part is really confusing for students, okay? So it's kind of like a little counterintuitive, right? So when you lose electrons, okay, when you're losing them, okay, you're actually getting more positive. So I usually tell students to kind of think the opposite. Okay, so if you lose electrons, you get more positive. All right, and when you gain electrons, you're getting more negative energy, so therefore you're going to become more negative. Okay, so lose electrons, positive. Gain electrons, negative. All right, so it's kind of the opposite of what you think. All right, so we're going to start off with iodine. We're going to look at iodine. The first thing we need to figure out is how many valence electrons does iodine have? Okay, so I'm going to go look back at my periodic table. So I'm going to find iodine. Iodine is here. It's in the halogen group. It has 7 valence electrons. Okay, so 7 valence electrons. So it wants to have 8. So I know it has more than 4 valence electrons. So that means it's going to gain 1 electron. Okay, so it's going to gain 1 electron. So when it gains that 1 electron, like we said before, gain an electron becomes more negative. So my charge on iodine is going to be a -1. So I'm going to put that up here as a -1. Okay, let me redo that one. Okay, let's make that a -1. Okay, so that's a -1. All right, we're going to do 2 of these together. So I have SB, which is antimony. So I'm going to go back to my periodic table. So you guys should be able to look at yours in front of you. Okay, so I'm going to find SB. SB is right here. Okay, I'm going to see that it has 5 valence electrons. So it has more than 4, so that means it's going to gain. So 1, 2, 3. So it needs to gain 3 more electrons. Okay, so it can complete the octet rule. So when it gains electrons, it's going to become more negative. Okay, so that means I'm going to get a -3. Let me erase this. Okay, so we got antimony, and this is going to be a -3. All right, I want to do one more because I want to show you a positive one. I want to show you a cation as well. All right, so let's go ahead. We're going to look at strontium. So I'm going to go back to the periodic table. I'm going to find strontium. Strontium is in the second group. So it has 2 electrons. Now this is less than 4. So if it has less than 4, oh, and strontium is a metal because it's in the alkaline earth metals. So if it's a metal, that means it's going to lose these 2 electrons. So remember, it's kind of counterintuitive. If it's losing the electrons, it actually becomes more positive. All right, so let me see. And then these are supposed to be kind of like exponents. They're supposed to be small. Okay, so strontium, I'm going to put the charge of a +2. Okay, that was pretty decent. Okay, so that's a +2 charge. So now I want you guys to pause the video, and I want you to go ahead and do the other ones on your own using your periodic table. So it's really important you guys know how to do these. Okay, welcome back. Let's go ahead and check all of your results. Okay, so let's check your results. So hydrogen has 1 valence electron. Okay, so hydrogen is going to have a +1 charge. Gallium has 3 valence electrons. Okay, so it's going to have a +3 charge because it's a metal and it's losing, okay, 3 electrons. And when it loses 3 electrons, it becomes more positive. All right, so silicon. Let me go back real quick. Silicon, I think, has 6. Yeah, so it has 6, so it's going to gain 2 electrons. Okay, so that means if you gain electrons are negative, so you're going to become even more negative. Okay, so it's going to gain 2 electrons, so it's going to be a -2 charge. All right, phosphorus. Let's check to see how many. So phosphorus has 5 valence electrons, so it needs to gain 3 electrons. When you gain negative energies, you become more negative. So phosphorus is going to have a -3 charge. All right, so argon's a little bit tricky, right? So if we look at argon on the periodic table, argon has, it has 8 valence electrons. So what kind of charge is argon going to get? it already completes its octet rule. It's already super happy and stable. Okay, so that means argon is not going to gain a charge at all. Okay, argon does not turn into an ion. So if we think about that, do you think that we'll see argon making ionic bonds? No. Okay, so we're going to put no charge on argon. So we're just going to put no charge. This is really testing my abilities. I'll only get better. This is beginning stages. Okay, no charge. I love it. Okay. All right, no charge on that one. All right, great job. I hope you guys were able to get most of those correct. All right, now, ionic bonding basics. All right, so ionic bonding basics. So bonding between a metal and a nonmetal on the periodic table, the opposite charges on the ions hold the bond together. The electron gets transferred to the nonmetal. Nonmetals have very high electronegativities. So electronegativity means that they really want more electrons. Okay, so they need more electrons, causing the electron to transfer from the metal to the nonmetal. Okay, so the nonmetal is very, very electronegative, so it takes the electron from the metal. So that's just background, so we know what's going on with the ionic bonding. All right, now we're going to use all of our knowledge of Lewis dot structures, forming ions, just the stuff that we reviewed. Okay, so we have ionic bonding using Lewis dot structures. So the first one, we have sodium is reacting with chlorine, which is sodium chloride. So guys, this is table salt. Okay, table salt. So our first one, which one is the metal? So which one is the metal? So we look at sodium and chloride. So a way you can figure out the metal is you look at the periodic table. On the left side of the periodic table, okay, on the left side, we are going to have the metals. Okay, so these are going to be the metals. All right, and on the right side, these are going to be your nonmetals. All right, I'm getting better with this thing, I think. All right, so now we're going back to our bonding. Okay, so sodium, oh, sorry, we didn't look to see where sodium is. So sodium is on the left side, so it's right here, so we know that it's a metal. So sodium is going to be our metal, and chlorine is going to be our non-metal. All right, so now we have a couple of steps. Our first step is we're going to draw the Lewis dot structure. So sodium has one valence electron. Okay, so we're going to put that one valence electron. And then chlorine is in the halogen group, and it has 7 valence electrons. So we have 1, 2, 3, 4, 5, 6, and 7. Okay, now this is where we're going to show the transferring. Okay, so we're going to show the transfer of this electron from the metal to the non-metal. Okay, so now we're going to have this, we'll have an arrow. Okay. Okay, so we'll show an arrow that's transferring this electron from the metal to the non-metal. All right, so we did the dots and we did the arrows. Great, we're done with step 1. Now, step 2, now we're going to do brackets and charges. All right, so we have sodium And I'm thinking about what happened in this one. So that sodium lost that electron. So that means that we don't have anything to show around sodium. Okay, so sodium lost all of its electrons, so there should be no, okay, no dots around sodium. You'll lose points if you put dots around sodium, okay, because it lost all of its electrons. All right, now, what is the charge on sodium if it lost one electron? Remember, when you lose an electron, it's going to get positive, okay, little opposite than what you think. Okay, so now we have, I'm gonna put my charge up here. Remember, this is the ion. We just did practicing on this. That's why we practiced it. Okay, so now I have a charge of +1 on sodium. All right, the next one, we have chlorine. So I'm gonna have my brackets on chlorine. Make them a little bit big because I gotta put all those dots in there. All right, so everything I see here, I have to put inside of here, okay? So now I'm gonna put all of my dots around chlorine. So I have 1, 2, I have 2 dots up here, I have 2 dots there. I have 2 dots, 2 electrons here. And then this one, and then I'm gonna make this one an X because that one came from sodium, okay? So that way I know that one transferred in. All right, now chlorine gained, okay? Chlorine gained an electron. So when it gains a negative energy, it's gonna become more negative. All right, so we're gonna have to put our charge up here. So my charge is a -1. All right, now formulas. So formula is like H2O. It's the two symbols put together based on their ratios. Excuse me. All right, so here we have a 1-to-1 ratio because we have 1 sodium reacting with 1 chlorine. Okay, so I'm gonna write down that I have a 1, okay, to 1 ratio. So that means I'll have 1 sodium for 1 chlorine. So to write the formula, I'm going to put Na Cl. Okay, still working on the writing, guys. Bear with me. Okay, now our charges. To have a really balanced compound, we want the charges to equal 0. Okay, we want it to be a stable compound. For it to be a stable compound, we have to balance the charges and they should be 0. So I have a +1 charge, and then I have a -1 charge. Okay, so that's great. That's exactly what we wanted. Okay, so +1 -1, that's going to give us our 0. So that means this is going to be really important later because it's going to help us make sure that we have the right ratio. Okay, all right, so we're going to go ahead and we're going to move on to the next slide. So right now, I want you guys to try this one on your own. Okay, try this one on your own. I want you to stop the video, try it on your own and see what you got. Okay, welcome back. Let's see what you got. All right, so we have metal. So the metal is going to be beryllium. And the non-metal is going to be the selenium because it's on the right side of the periodic table. Okay, so now we have beryllium. It has 2 valence electrons because it's in the 2nd group on the periodic table. So we'll draw in those. And then we have selenium. Selenium has 6 valence electrons. So 1, 2, 3. Remember, we can't pair up until we have 1 on each side. 4, 5, and 6. All right, now we're gonna have to do our arrows. I'm gonna do this one in a different color so that way we can really see our transfer better than we did last time. Okay, so we have 2 spots open. Also, make sure you have to transfer this electron into one that has a single. Okay, I call these all the single ladies. Okay, all the single ladies, they want to get together and they want to go out dancing. Okay, so then we can sing the song together. All the single ladies, all the single ladies. Okay, so then we'll take this electron, this single electron, and it's going to go here, so that way they can party together. Okay, so this will be one of the electrons that transferred in, and then all the single ladies, all the single ladies. All right, and then we're going to transfer another one in right here. Okay, I'm going to draw that as an X. Okay, that's an X there. All right, so now all the single ladies are paired up. They're out dancing, having a great time. All right, now next we're going to do our brackets. Okay, so now we have the beryllium. The beryllium lost all of those outer electrons. So we're just going to put our brackets on beryllium. And then it lost 2 electrons. So remember, when you lose electrons, you become more positive. The main reason is because you have more protons than electrons now. All right, so now beryllium, we're going to put a +2 there. Okay, and now we have selenium, which is our nonmetal. So it gained electrons because it's more electronegative. Okay, so we're gonna put in all of these here. We gotta make sure we represent all of our electrons. So 1, 2, 3, 4, 5. Oops, that one I messed up. I'm gonna have to erase that because that should be a blue X. Okay. All right, and let's do this. I'm just gonna erase just that guy. Is it gonna let me? Huh. It's not letting me erase it. Why? There it is. Okay. All right, it let me erase it. So now we're gonna make sure we put in, yours don't have to be a different color. I'm doing a different color just for fun. You guys can just put X's though. Okay, that's kind of an X. All right, so then those are our X's. So it gained, okay, so it gained 2 electrons. When you gain more negative energy, it's going to become more negative, and electrons are negative. So therefore, this is going to be a negative charge. So that's why we have a -2. All right, there we are. Brackets and charges. We're done with our second step. Now let's check our formula. So we have 1 beryllium reacting with 1 selenium. So we have a 1-to-1 ratio. And then, so that means I have beryllium selenide. Okay, we're going to go over naming a little bit later, okay? All right, balancing charges. So I have a +2 here and a -2 here. So I have +2 -2 equals 0. All right, great. So that's it for class. I'm going to give you guys a couple of problems to do for homework. And those are the ones that we're going to hit on as soon as you get in class tomorrow. Okay. So I want you guys to write down this one, that you have aluminum reacts with nitrogen. So pause the video now and write this down because I want you to do this one for homework. Okay, the second one I want you to do for homework is barium reacting with sulfur. Okay, pause the video now and make sure that you write this down. I want to make sure that you guys are getting the formula and balancing the charges too. Okay, third one I want you to do for homework. Cesium is reacting with iodine. Okay, cesium reacts with iodine. And the last one I want you guys to do for homework is beryllium reacts with oxygen. Okay, I'm gonna send the answers to you guys tomorrow. So you have Monday and Tuesday to do these problems. Okay, so look back at the notes. Make sure you guys know what you're doing. Tomorrow I'm gonna send you the video with the answers for these. Okay. Hope you're all staying well. I'm glad that I'm able to do these videos now since I found this mouse pin, which is pretty awesome. All right. Send me an email if you have any questions.